Good morning, everybody. Thanks for joining early Sunday morning. We got Dave's Vintage Apple Tech and Garth Beagle already here. How's it going, guys? Yeah, what the heck are you doing up this early? Aren't you both West Coasters? So yeah, today we have this 46 motherboard on the big bad bench. And what we've done to this thing is basically taken it all apart and sort of gone over all the traces. There was a battery bomb here that caused a bunch of corrosion on a lot of these traces. So I cleaned off all the corrosion and went in and put solder mask on a lot of things. And so today, hopefully, we can reassemble this thing and get it booted up. One of the things I was talking about last time was whether I was going to have to take off the keyboard ROM socket. Hold up a second. Does that clear up my audio at all? I don't know why there's such a delay. Testing. Let me unplug one other thing. Testing. How about that? Buzz. You'd think I'd have this stuff down by now. I have no idea what I'm doing. Okay, I think that sounds good. Okay, thank you, Dave. So yeah, sorry about that. So yeah, the first thing we got to do is pop this little resistor back on. There was a bunch of corrosion underneath that keyboard controller socket, so we got to put a new socket on. Of course, when you take those 40-pin sockets off, it's a lot easier to destroy those sockets than to try to take them off all into one place, so I cut it in half. So we got a new socket. Hopefully that'll make our keyboard controller happy. We have a resistor here. Oh yeah, this is the other problem. So after cleaning up all those things, you can see that I've destroyed most of the silk screening that said which is which, but luckily I took a pretty good picture beforehand about what thing goes where. So we should have all the labels set. All right, so let's start off getting this resistor in. Resistor 548, which you cannot see the silk screening on anymore. So hopefully we can get these all in the right places. One of the other things I did while I was trying to just go through, get ready for this stream was I went in and basically tested all of the components with an LCR meter just to make sure that nothing was totally screwed up. Man, it's a tight spot. So all my resistors still resisted. All my diodes still dioded. The only thing that we had was a couple of capacitors I had destroyed in the removal process. So, all right, so let's. Oh yeah, and here's the back. There was corrosion on all these traces, so cleaned up all that. got everything all nice and shiny now with a new coating of solder on it. Okay. So where's that thing I need to solder? There it is. All right. Put a couple drops of flux on here. So I also had cleaned up a lot of the traces and stuff, all the legs. Okay, here we go. We're starting to get some flow now. Seems like some of those things don't want to flow. Oh, Dave's asking me how the Farmer Tan is going, and I think the Farmer Tan LC3 is ready to get packed up and sent off to Dave. It's ready to go to its new home. Let's see, where are we working here? There we go. So basically with that one, I was just doing some more snooper Apple hardware tests, or what, Apple personal hardware tests. Just making sure that everything was working right. I also still had concerns with that one about like the weird power on issue that I had seen at one point. So that all seems good. I haven't had that issue since I added the CR2032 battery. Okay, so now we gotta get this socket in there. Let's go back to this. So these things are kind of fiddly. The legs on these are so thin that they want to break, or not necessarily even break, but like twist up, and it's hard to get all of them seated properly nicely if your holes aren't perfectly clean. Which these should be pretty darn clean. I spent a lot of effort trying to clean up all the holes so that this reassembly process would go fairly smoothly. Oh, did we get it? Let's see. We have all of our legs poking out here. Yeah, I think we do. All right, awesome. That went smoother than I thought it would. All right, so let's go back under the microscope. It's a little bit easier. Oh, it's Eric's Edge. How's it going, Eric? Good to see you. Okay, so this was difficult getting off. I hate removing big sockets and stuff with lots of pins. So it was a bit of a fight. So we're going to go through. We're just going to put a little flux on all these just to try to help things go a little bit smoother as we put it back together. And so what I'm going to do is hit this pin here. And then we'll come down. Where's my... There we go. This is too early. I can't find which way's up. Whose idea was it to stream this early in the morning? Okay, so what I'm going to do now is come back from behind and just push on the socket a little bit, make sure that we're totally seated. Okay, good that side. Come back over here, get this one. Okay. Alright, now it's just a matter of hitting up all these solder joints. I feel like I should be using a slightly bigger soldering tip for this system. So I did, use my multimeter and go around and sort of beep out everything just to make sure that none of these traces had totally rotted. I found one that was iffy, so I've resolved that one. So hopefully we have no bad traces. But, I mean, I wouldn't put it past myself to have missed one or two. We'll see. Been up since 7 a.m., but you're a time zone over, I think, for me. I'm in New England, so I've been up since 6:30 New England time. So, if you're into watching me solder sockets, make sure to get subscribed if you're not already, because at some point I'm going to be showing how to set up the Mac Plus internal SCSI board that I designed. And it is a lot of soldering, 40 pins at a time, basically. Oh, you're on the western edge of eastern. Okay. Thanks, Eric, for doing the YouTubey stuff. I'm really bad at this. I need to come up with a creative sort of smash that like button thing like Bruce has. Make it sound more fun. I can do the get subscribed thing. Alright, how do all these look? That one I don't really like. Put a little bit more on that one. More on that one. More on that one. I think my soldering iron needed to wake up today. Seems to be working better now. Oh yeah, I'm a natural. Yeah. Oh, notice my camera is a little bit off. Got to cut back on all the swearing. Oh man, that's why I didn't show the desoldering of my 40-pin socket. YouTube would have preemptively uh, demonetized me permanently. Oh yeah, the solder's flowing nicer now. We'll be back. We'll be in all together in no time here. Flow, solder, flow. Whew, almost there. Almost there. Alright, now let's check and see if we melted our socket. Looks good. I even put it on the right way, so that's good. Not super melted or anything. So, okay, ready for the next thing. What's the next thing? Let's go look at our picture. Nope, not that picture. This one. Okay, so the next thing we need to do is add this jumper in here. Oh, not my face. Okay, here we go. Okay, cool. Thanks, Dave. Yeah, I'm gonna have that shipped out tomorrow morning. So the original jumpers that were on this board, you can see they're all corroded and nasty, so we're gonna replace them. I don't think they originally had jumpers in these positions, so we probably don't need to do it right now, but it doesn't hurt to put things back together like they were originally. Okay, so let's just double check. Yep, so we have a jumper and then an inductor. Why do I keep going to my face? Nobody wants to see my face. Okay. Okay. Nope, I want to come up just a little bit more. I hate it when they're not perfectly flush. Okay. Get that other one. So now what should we do? So it seems like we should sort of work over from here. So we have, I think that's capacitor 3. Let's just check our other picture. Yep, capacitor 3. And based off of this is capacitor 3. Yeah, I really want to get that project published, the Mac Plus internal SCSI, because there's people that really want to try it out for themselves. But it is a complicated job. Probably will involve a lot of swearing, but all right, there's our capacitor 3 in its position. Maybe. Yep, there's the two little legs poking out. There's probably, I could probably go faster and do multiple of these at one time, but I tend to work kind of slowly. Okay, so next we have capacitor 8. Capacitor 8 had a little damage when I took it out. These, I think these are MLCC caps. So those were ones I needed to replace, and so I ordered some new ones, and they came in this week. And so I'll stick that one in there. Okay. We're making progress here. So let's add these inductors. So we got L3 and L4. I want to check that picture real quick. I want to see where... Oh, not that one. Oh, okay, R13. All right, it's right next to the inductor. Okay. Okay, so it's L4. Come on, phone. So we're going to put L4 on. Just gonna force that down a little bit more through there. Okay. Alright, they look back. Lovely. Now we go to R13. This is like it's like a little paint by numbers. Happy little R13. Oof. Pliers are a little dirty. Sorry about that. Let's try not to destroy the traces right now, since we just did all that work to try to bring them back into good shape. Yeah, the battery area was very not happy. It wasn't too bad when I first looked at it, but it needed a lot of help. Once I got all the solder mask off, there was corrosion on a lot of traces. All right, that one's laying down nice. Okay. So now we have JP126, so that should just be a jumper. JP126, just a jumper. So snip off 2 of these. Make sure that jumper's sitting nicely, which it's not. Okay. There we go. Now it's sitting nicely. Okay. Now what do we got? Let's check our picture. So we got that. We got that. So we got a resistor, we got R12, I think. Oh yeah, there it is. Okay, so we got R12, and then we got a couple diodes, and then we got R4. Okay, I found them. It's okay. We're good. Okay, so R12. let's see if we can put these diodes in. May as well try to solder them all at once. So if we look at our, not that picture, that picture. Ooh. Just trying to see which way the diodes go. Okay, so we can see that the black goes away from the square right there. Okay. Oh, I gotta check the picture again, see which one. I think both these diodes are the same, but may as well be. Oh, it's kind of hard to say. Okay, so I guess that one's, yeah, that's diode 4. Okay. I'm stressing as I'm getting more of these in. Worried I might have lost something. I don't have any evidence to suggest I lost any, but it's a lot of little fiddly bits, and I had labeled a lot more because I thought I was going to have to take more of the board apart. But luckily, I didn't have to take as much apart as I thought I would. This diode is making me crazy. I just filled in its hole. Gotta get the old solder pulled out. Okay. That's a lot better. Thought I had cleaned all the residual solder off of these, but I guess I'm still missing a little bit. There we go. That should help. There we go, a little diode. You went to your home. And before I solder that, let's just check it one more time. Yep. Okay, good. Alright, let's put the other diode in. It should be facing the opposite direction. a little flux to these. 'Cause I think some of these holes were a little angry. Well, they look pretty good. But the flux doesn't hurt. Okay. 2 diodes in. Now what do we got? Let's check our picture. I think it's an inductor. Oh, nope, we got a resistor and then an inductor. Okay. So that is resistor 4. And here's resistor 4. This is very fiddly. Lots of little things to put in, lots of little holes. And of course there's no like room to work on any of these things. Gotta get them in at just the right angle. Oh, come on. Okay. When they clipped all the components on this board, they clipped them really close, so there's not a whole lot of room to work with from the components I had to desolder. Did that just fall out? Where am I working here? There we go. It's at its home now. All right, Garth, have a good day. Good to see you. I might see you over. I don't know if you're going to stop at Dave's stream or not, but I plan on stopping there for a little bit today. All right, so now we got our inductor, L3. Just want to clean off. No, that one looks good. Make sure that we're in and connected. Yep, looking good. Put just a little bit of flux. And a little bit of flux. Alrighty. Got our inductor in. So now what? Let's put our power socket in. And I'm pretty sure it faces, yeah, down that way. come in like this. And our socket should fit nicely. Should fit nicely. There we go. Not too mangled. The other thing I did when I was cleaning up the traces is I made sure that nothing was shorted out across the power planes, because one of the things that can happen is if there's a shorted capacitor somewhere on here, it can prevent the system from booting or cause other issues. Okay, so we all squished tight on there. Yeah, that looks good. All of our leads are reasonably straight with one another. I think we're going to use some bigger solder for this job. These are giant holes. So as I do this, I'm going to hit like one spot up here, another one down here, just to minimize heating up that piece of plastic. It's not the most durable type of plastic that they use for these AT power connectors. So you don't want to heat it up too much if you don't have to. All right, Dave, good to see you. Yeah, I'll stop by a little later for your stream for a little bit. I can't stay super long, but I have some other Mac stuff I can be working on today, so may as well try to get some of that done. Alrighty. Alright, how's this look? Okay, we got decent solder joints on all those things. Alright, what should we do now? Let's get L1 and C2 on here. Okay. L1. You can see, look how close they trimmed all those things off. There's very little space around there. Alrighty. There's that one. So let's go to C2. Thing. Come on, you thing. Let's clean a little bit of that solder off of there. There we go. That's better. Okay, this one has lots of space. We're not going to be running out of space with that capacitor. Okay, so that one's on there, nice. I guess we should take care of these things before we go and put the keyboard connector on. So what do we got left? We have an electrolytic capacitor, an MLCC cap, ceramic cap, and an R, a resistor. Alright, so let's check our pictures. Okay, so here's R18. So let's stick that one on there. Okay, and so I know it's not visible on here, but based off of our picture, this is where R18 goes. So this is a good example of why you should always take pictures of these things before you start working on them. You never know how much damage is going to happen during the repair. Of course, my fingers are sticky, and that resistor just got stuck to my finger. So once it was in, I pulled it right out. Okay, don't go anywhere. You stay here. Oh, it escaped. It escaped. All right. Take a different approach on this one. Get some. There we go. Now it's tacked up in there real nice. Alright, so there's R18. So then next to that we have Capacitor 7. Which we need to replace with a new one because it got destroyed when I took it out. Oh, now I'm curious. Where? See, well, that's one of the bad things there, right? We can see that there's a bunch of holes that it theoretically could be at, and I'm pretty sure it's going to be this and this, but you never want to make an assumption. Oh, no, actually, it's going to be this and this because there's a electrolytic right there. Okay, so, yeah. So let's just double check that on the picture. Yep. So 6 and 7 are the shorter pins, and then we have that other electrolytic right there. Okay. That like that. I also, this electrolytic, I checked with my LCR meter, and it looked real bad. A lot of well, the capacitance was only about half of what it should be, and the voltage loss was like 30% or something like that. So I might also have to replace some of these other capacitors, but generally with these PCs, even if the capacitors are a little wonky, these smaller capacitors, it shouldn't affect the ability of the system to boot up. So let's do these. just did a thing. Let's check under the microscope real quick. I just want to make sure. Let's clip these. Okay, we all clipped. No, that looks good. I was worried I might have just created a little bridge right there, but no, that looks great. Okay, one more thing to go here. We're getting close, people. Thank you for everyone that's still hanging in there. All right, so one more thing here, and that's Capacitor 6. Epictronics, how's it going? So, how bad is the damage? The damage was real bad. I think there was really only one trace, but there was corrosion on a lot of traces. So I wound up having to, scrape a lot of solder mask off, and then, just sort of, you can see like here where I've gone in and coated everything with a nice little coat of solder. But I think we should be in good shape now. Just have one more component to put back on here, and then I think we can. Oh well, we also have to put the keyboard connector back in. Oh, I got to take a little bit more solder off of this thing. I thought I had cleaned that one up. But there we go. See, I didn't do all the repair on stream. I did the disassembly on stream, but there was a lot of fiddly cleaning up angry traces that happened off stream. Okay, so you can see we're poking through here, and like everything else, the leads are a little bit short, but it's fine. A little bit of flux on there. I don't like that. That leg was a little wonky. There we go. Never cheap out on the flux. All right. So it's not going to win any beauty prizes, this motherboard, but I'm hoping it'll be functional. Like I said before, the keyboard port had some green in it. The whole board wound up getting a vinegar bath. But again, there were like those bubbles that happen underneath the traces, so that all needed to be resolved. Okay, here's our keyboard port. And then I just noticed another thing that needs to be fixed, so we're not quite ready to turn this on. Well, it looked like a crystal is falling off. Yeah, cleaning traces and resolving all that takes such a long time. And it's not necessarily the most compelling work. I mean, if you're into dentistry, then I would imagine that cleaning, scraping and cleaning traces is probably something you'd be into. But I find it kind of tedious. Okay, so that's on real nice. All right, cool. So let's look at this. So interestingly, let's see. It looks like it pulled the lead right through the solder. So let's put some fresh solder on here. There we go. Okay. So I think we're basically clear now. Alright. So that little crystal should be happy now. Yeah, there we go. So both the legs, both the leads are poking through there now. Alrighty. What else do we got here? There's some gunk. But I think we should be good to go. Oh man. Alright, so let's see if this is my first time really crying on a live stream. It could happen. It could definitely happen. Gotta put this in. So I like to use a little bit of deoxit. I don't have any of the fader lube stuff, but I like to put this into sockets before I put chips in, because it just has that little bit of lubricant that can help prevent bending your legs. Let's give these a quick look before I put it in. Yeah, no, all these legs look good. So if anything happens, it's all my fault. And let's chuck some RAM in this thing. Jay, how's it going? Good to see you. These are not shenanigans today, man. I'm working hard. This is Sunday. You know, I know you don't like waking up this early, especially I would imagine on a weekend. No shenanigans here, just hard work. All right, what else are we gonna do here? Let's put a postcode card in here. Always check on your postcode cards to make sure that you're facing it the right way. The other thing is, I was playing with my VGA capture this morning, and it was not liking my ISA video cards. So we're gonna have to do this the hard way. Let's add a speaker. So we've got a power supply. So black. Don't you hate it when you work harder when you're supposed to be relaxing? That's pretty much the story of my last 6 months. Alright, so we got a power supply. So we also are going to have this low-tech solution for checking display out. I'm sorry I don't have something more elegant right now. Let's pop in a VGA card. double checking to make sure I don't have anything electric down here, or conductive. So we have just a little basic Trident ISA card. And let's plug this in. I guess I'm being a little too hopeful by plugging in a VGA card. I know sort of the theory is you probably, if there were something shorted, you don't want to send the wrong voltage and fry your card. All right, here we go. 3, 2, 1. Oh, shit. We got post, sort of. Can you hear that? We got RAM count. And we got beep. We got VGA. Yes! Holy crap. Let's see here. This is very unelegant. I apologize. I can't believe this thing powered up like that. Oh, imagine that. The CMOS battery state low. That's funny. All right. You made it just in time, Eric. I can't believe this thing is working. All right, so what we're going to do now, get rid of some stuff so I can... Let's see here. I wish my VGA capture were working properly. It would make this a lot easier. So, going to plug in a keyboard. Let's see, can we read sideways? Let's put that on there like that. I'm kind of interested to see what the BIOS looks like on this thing. You never know. So here's just one of these things. Get it right, BIOS. CMOS battery state leaked. That's right. How's it going, Justin D. Morgan? Oh, man. All right, let's see if it turns on for a second time. Let's just double check, make sure I didn't short anything out here. All right, we got our postcode thing doing postcodey things. We got something on the screen. All right, let's run the setup utility. Oh, it's one of these ugly ones. Ew. All right, well, whatever. Let's get out of here. No, let's not do that. Let's write an exit. Yes. Floppy controller, bad. Yeah, no, that's no problem because we don't have a floppy controller. Let's go. 256K cache, 66 megahertz CPU. Testing extended memory. Oh, man. Well, this is awesome. Oh, I can't believe this thing powered on. What's the board with the groovy colored lights? That is a postcode analyzer. So basically, I could show you in a second. I'll tilt the board up. Let me get something started here. Let's see. Y'all got me messed up and working in so much Mac stuff. I forget how to do anything in DOS. Okay, yeah, here we go. CD DOS bench. So this is the utility made by Phil from Phil's Computer Lab. Lots of great utilities in here. So let's do N. Let's do speed sys. Let's see what this this hammers the cache pretty hard, so. Yeah, let's make the BIOS so ugly that no one will ever want to enter it. That is a smart way to keep people out of the BIOS. Alright, I don't really care about you testing the hard drive. I want to get to the memory stuff. No, we don't want to. Yes, we know the hard drive is doing that thing. Oh, man. All right, have a good day, Jay. Thanks for stopping by. It's good to see you, man. Come on, thing. What are we doing now? Man, I wish my VGA were working right. Okay, it's testing something. Doing hard drives tests. I don't want to do the hard drive tests. Did it lock? I don't think it locked. Give it some time. Anyway, so Eric, so this, it's kind of hard to see because it's refreshing, but basically PCs starting around the 286 era had different codes inherent into the BIOS that, as it was doing stuff during boot up, it would send these post codes through the system, and so some boards had ways to read the post codes directly, but this system basically lets you see those codes. Oh, okay, so yeah, it didn't lock up, but it was taking a while. So this just lets us see those post codes, and really the post codes, they're supposed to mean certain things, like, okay, I'm initializing the CPU, I'm initializing the chipset, or I'm checking the RAM, or I'm looking for the hard drive, and sometimes you can make sense of them, but the most important thing to get out of the post codes is that they're changing. So if you ever see that they get hung up on something, it typically tells you that there's something wrong somewhere in the initialization of the system. Yeah, the post codes just kind of show you how things are moving around. All right, so what do we see here? Blah, 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 blah. Let's go to benchmarks. All right, so we got, it's showing up faster than an Intel DX33, which is nice. There's probably some tweaking to do here, but no, that's great. All right, let's try this one. Okay, so you can see we're running like a 316 megahertz 286 basically. That's kind of funny that it's showing up as a 486 megahertz thing, because it's a 486, but that's totally unrelated. That's just silly. All right, let's see what Doom does. Of course, it's not going to have any fun audio or anything like that. Uh-oh. Insufficient memory. I gotta reboot. Alright, hold on a second here. get our error message for not having floppy. I could just do that thing. F1 to resume. I could set it in BIOS, but as soon as I power off the system, it's going to forget because we don't have a CMOS battery. Okay, let's cd DOS bench, and then DOS bench, and let's run our Doom. Oh man, I am so excited that this thing works. Woo! The rush of repairing old computers. You never, there's nothing that can compare to that. Come on, you crazy little Doom. Oh yeah, it's flying by with 486. I should probably make a monitor bench. Like I have a TV behind me. Then we could just have the upper camera doing all this stuff and the bench be the screen. That's something to think about for a future iteration of the Big Bad Bench. Yay. Okay, so it completed that. I'm going to turn my lights back on here. So, I don't know what to do with myself now. I was expecting that to not work. So I think what I want to do is set this up in a system and do some more testing, because obviously my little rig right here is not ideal for testing stuff. So I think what I'm going to do is end this stream. I'm actually going to stream again tomorrow morning because I have the real system that I wanted to do the 486 build off on, which is a Dell. What the heck is it? It's a Dell Dimension DMT 466. Which is a really interesting system because it basically has an early iteration of ATX. This kind of AT power supply requires a physical connection to 120 volts that powers it on, whereas ATX has soft power. And this system has soft power, which is kind of weird for a 486 system. So I've been wanting to get that system working for years, and so 486 build off is going to be a great excuse for me to do that. And I've realized just the other day that we're running out of September, so I really need to do that system. So going to do an emergency stream tomorrow morning to work on the Dell system. So I want to thank everyone that has stopped by today. Eric's Edge, Jay from the House of Moth, Justin D. Morgan from Justin D. Morgan, Epictronics. I can't believe you showed up to one of my streams. I mean, the rest of you goofballs I love, but Epictronics, that's cool that you stopped by. Dave's Vintage Apple Tech, and Garth Beagle, thank you all for stopping by. It's always great to see you. And I'll probably stop into Dave's Vintage Apple Tech very shortly because he's going to be streaming at noon Eastern, 9 West Coast. And so have a good day, all, and I'll talk to you soon.